Swarm learning is a cutting-edge technique that combines the power of decentralized machine learning and collaborative intelligence. If you're intrigued by this concept and want to apply it in your own projects, this tutorial will guide you through the implementation steps. By the end, you'll have a clear understanding of how to leverage swarm learning effectively. The first step in implementing swarm learning is to clearly define the problem you aim to solve. Establish specific objectives to guide the implementation process. Understanding the problem thoroughly will set the foundation for the entire project. Data plays a crucial role in swarm learning. Start by gathering relevant data from different sources and pre-process it to ensure consistency and quality. Cleanse the data, handle missing values, and remove any outliers. Also, split the dataset into training and testing subsets. To implement swarm learning, you need to create a swarm of participants, in other words, individual machines or devices that will contribute to the learning process. Design the structure of your cell swarm, considering factors like the number of participants, their capabilities, and how they will communicate and collaborate. Enable effective communication among swarm participants to exchange information, models, and data. Utilize secure and efficient communication protocols to ensure privacy and reliability. Technologies such as WebSockets, peer-to-peer networks, or decentralized data exchange frameworks can be employed. Each participant in the swarm trains a local model on their subset of data. Use popular machine learning libraries like TensorFlow, PyTorch, or scikit-learn for this process. Adjust hyperparameters and algorithms according to the specific requirements of your problem. After local models are trained, aggregate them to form a global model that reflects the swarm's collective intelligence. Choose an aggregation method like federated averaging, majority voting, or cross-model weighting, based on your problem and swarm characteristics. Evaluate the performance of the global model using the testing subset of data. Measure relevant metrics, such as accuracy, precision, recall, or fun score, to assess the model's effectiveness. Compare it with other baseline models or traditional machine learning approaches to evaluate the added value of swarm learning. Swarm learning is an iterative process. Continuously monitor the global model's performance, identify areas for improvement, and consider retraining local models or modifying the swarm structure. Regular evaluation and refinement based on new data and feedback are essential for enhancing performance. Once a reliable global model is established, deploy it in the desired environment. Monitor its performance in real-world scenarios and gather user feedback. Use this feedback to iterate on the model and swarm structure, ensuring ongoing improvements in effectiveness and efficiency. Remember, swarm learning is a rapidly evolving field, and new techniques and algorithms are being developed regularly. Stay updated with the latest research papers and publications too. Enhance your understanding and implementation of swarm learning. By following these implementation steps, you'll be able to unlock the potential of swarm learning and leverage its collaborative intelligence to solve complex problems effectively. Good luck with your swarm learning journey.